All right, here's the last type of phantom problem, which we now don't need for the AP test, but they're kind of cool. So if you haven't already read this and done 1 through 9, you can go ahead and just do number 10, but you should read through this. I'm not going to. And our goal is, so what are we trying to test? So state our hypotheses. So here we go with phantom. So our hypotheses are going to be, is there convincing evidence sitting closer causes students to get higher grades? Now what it really is going to be, though, is going to be the null and the ha. We could say sitting closer causes higher grades, but normally what we're going to do is just say this. We're going to say beta is 0 and beta is not 0, where beta is, and then we're just going to say, oh, sorry, actually, this should be one-sided. I think that sitting closer increases grades, so I'm thinking that the farther you are, the less your grade is. So as rows go up, this goes down, and so I think the true slope is going to be negative. That's how we say the farther you sit, the worse your grade. And so beta is the, now you just say true slope or slope of true slope of population regression line, relating test score and assigned row. So I'm not going to be terribly concerned about this since it's no longer on the AP exam again, so we don't have to super get that. Okay. But that's the basic way this one would work. And these ones are kind of tricky because it seems like a chi-square, but they're both quantitative variables. So what's the evidence? Well, the sample, B, is negative. When I took a sample, I got a negative slope. That's this number right here. That's our B. And since that was negative, then, yeah. What are the two explanations? It could be causing it or chance. So cause or chance alone. Like there really is a relationship that the farther back you sit is causing your score to go down, or it could just be just randomly that people, the kids that were worse were sitting farther away. You know, it could just be chance. So how do we do this? This is good inference review of everything. We say, well, how rare is it that we would get a negative slope if this was just random? How rare is that? Now our R-square, observe, is only 4.7 here. So that's not super good. So there's not a very strong relationship here, which you did in part of your 1 through 9. But let's see if there is one. So what is the standardized test statistic for a significance test? It's going to be a t-score. Is the formula on this formula sheet? Well, only in like this normal form here. Oops. This normal form here is on the formula sheet, and here it's a t-score. So technically, my t-score is always just this formula, right? It's just always stat minus parameter over standard error. That's this, stat minus parameter over standard error. So mine will be my slope minus the null, which is usually 0, over the standard error, which is just on the computer printout. And then I find the probability, the p-value, by shading the right thing. But my calculator could do that part, do TCDF or whatever. Now the DF is just going to be n minus 2. What degrees of freedom? N minus 2. So you don't have to copy that whole chart down, but that's the gist. So what is the standardized test statistic, and what is the p-value for this problem? So the standardized test statistic is B minus 0 all over standard error. Okay, so I need to go get those numbers. So B is that negative 1.1171, and the standard error of the slope is not this. This is the standard deviation of the residuals. This is, when predicting this, we are typically off by 10. Hopefully you got that right. We want this number, 0.9472. So I'm just going to copy those two numbers down here. And then when I type those into a calculator, beep, boop, beep, boop, boop, beep, boop, it tells me negative 1.18. Okay, so that's my test statistic t equals. If I was doing phantom, this would be the t. And then, oh, I need a p-value. So the p-value is what? Off to the side, I just need to know how rare is negative 1.18. How do I do that? Okay, that's a TCDF. So TCDF on the calculator. And I just go, negative 1.18 is my upper. So I want negative 9999, comma, wow, that looked terrible, negative 1.18, comma, and then I need my DF. And so my DF is n minus 2. And if I look back at the problem, there were 22 students, so my DF is 22 minus 2, n minus 2, is 20. Now, if I just typed all that into the calculator, I would get an answer, which I don't have written down, so I'm going to pause and type it in. All right, I got 0.125. All right, is there convincing evidence? Well, since 0.125 is greater than alpha, that's not very rare, 12%, we, what? Fail to reject the null. We do not have convincing evidence that, and then I would probably write out, sitting closer to the front improves test scores. I just write that phrase here. Even though we technically said beta is negative. But that's the same thing. And that is how you do a phantom in chapter 12. Now, something cool to note. Let's back on up. T, p-value. Okay. Way back here, observe, here's a t, here's a p-value. That t matches, so for phantom, this is not necessarily true for confidence interval. So for phantom, we can use this t-value. So you don't even have to do that calculation. You could just report it. And then this is phantom. This is for a two-sided. And so if I just did betas not 0, I could use this. If I had betas less than 0, all I have to do is divide that in half. What's half of 248? 124. Well, that's basically what I had. I had 125. But that's close enough. And so, actually, for phantom, you could just use those two numbers. So on your homework, you could go ahead and try that. All right, to modify the homework real quick, I'll try to post this in Classroom also. Number 13 is a significance test, but it also has a lot of chapter 3 things. So we're just going to say this, though. We're going to say skip the conditions entirely. So when you're supposed to do the phantom, just skip the A step of phantom. And then 15 is a follow-up to 13, and I would say this phrase here, skip the conditions, would also apply to 15. So when you're supposed to do panic, just skip the A step and just do the rest of panic. And then 19, we're just going to throw out entirely, which is just another one, but then given the data. So we'll just skip number 19. 21, 26, this is the multiple choice. I think it would still be good to do those. So I just want you to try one phantom, one panic, but both of them have follow-up questions from back in chapter 3, which will be good to keep practicing those cookie cutters. They're the weird ones. We haven't done them in a while. So additionally, you need to make time to meet with somebody and do this assignment together. Listing all 15 that we need to know for the AP exam. It'll be good practice. However, these are not on exam apparently this year. So we'll see how that goes. But yeah, so but it's still good to be able to tell which is which for the others. So try talking through these 10 problems with somebody else, and I'll go over those on, I think I said Wednesday.